Question number first, list the outcomes you can see in these experiments. Here we are on last exercise 5.3 of chapter name data handling, mathematics class 8th, chapter 5. So we are given with a spinning wheel. In real life situation, spinning wheel looks like this. It's a gadget which we turn, and whenever this wheel will stop, wherever this pointer will mark, that will be considered as our outcome. This gadget is majorly used in lotteries or casinos. Anyways, let's come to the question part. We have to find the outcomes that we can see in this given wheel. Remember, this question is not asking to find the probability. Outcome is all the possible instances that a particular thing is having. In this case, we have a wheel. It is divided into various sectors. So it has totally 1, 2, 3, 4, 5 sectors, and we have some alphabets which are repeating. For an instance A, therefore we must write it one time only because both these mean the same thing. Therefore, the possible outcomes out of this spinning wheel is A, so the same has been written over here. We have unique B, so we wrote B. Similarly, we have C and D, so we wrote C and D. Remember, we need not to write A 2 times because both these infer the same meaning, although sectors are different. So the outcomes for A part are A, B, C and D. That solves our A part. Second, tossing two coins together. So what you did, you took two coins on your both hands and you tossed them at the same time. Although it doesn't matter if you toss it 2 times, but for the sake of this question, let's try to perform as stated. We tossed it 2 times, then we have to list the possible outcomes. Therefore, when we toss 2 coins together, we have 4 possibilities. On the first hand, as we have shown over here, head could come, and on the second hand, tail could come. This is one of the possibilities. So the same thing has been written in short form HT. H denotes head, T denotes tail. Simple enough. Now, another possibility could be in first hand, you may get heads. Also, in second hand as well, you got head. That is, on both hands, you get head. So this is another possibility. So we wrote HH for that. And third possibility could be, on first hand, you could get tails. Here we have tail. And on second hand, you could get heads. Also, you know very well, head denotes the picture part on a coin, and tail means wherever the value is written. Likewise, the last probability while tossing 2 coins together could be, on both hands you may get tail and tail. So the same has been denoted with double T over here. So there are 4 possibilities if we toss 2 coins at the same time. Therefore we wrote here HT means head on first coin and tail on second coin, and so on. The same has been explained. And what are the outcomes? Outcomes are the instances that happens when we perform any random experiment. And what is a random experiment? An experiment on which we do not have any control, yet we know the possible outcomes. Remember, we are using word possible. The same has been described in the introduction part of this exercise, that is chance and probability. You must watch it prior watching this exercise. With this, our first question has been solved. Question number 2. When a die is thrown, list the outcomes of an event of getting. Number first, a prime number. Number second, not a prime number. Similarly, a number greater than 5 and a number not greater than 5. So these are the faces of a die. You know very well by now because you have played various games out of it. Now let's dive into the question part. A prime number. Well, we know very well from our arithmetic chapters what are prime numbers. The numbers which are divisible by itself and 1. So we have 2, 3 and 5. We are considering from 1 to 6 because die consists of these faces only. So we write outcomes of an event of getting a prime number are 2, 3, 5. Simple enough. Similarly, not a prime number. So 1 is not a prime number. So we wrote the same over here. Similarly, 4 is also not a prime number. Therefore, we wrote 4. And the last one is 6. This is not again a prime number. Or in other ways, if these are prime numbers, the rest of the remaining will not be a prime numbers. So these are basic questions. Now, what are the outcomes of number greater than 5? So 5 should not be included because we are only asked to find numbers greater than 5. So only one possible face is there, that is 6. So we wrote a number greater than 5 is 6. Last part, a number not greater than 5. What does it mean? It is a little bit trickier. It is saying not greater than 5. It means smaller or equal to 5. Remember, a thought might strike into your mind that it should be only smaller. But this statement should also include less than or equal to 5. It is saying not greater than 5. It hasn't said that it should not be equal to 5. So never assume the things. Always try to find the deep meaning inside the statement. So a number not greater than 5 should be from 1 to 5, including 5 itself. In this question, this is the only point where you may go wrong. So remember, when it is written not greater than, it doesn't mean it is not saying equal to. Again, this symbol is for implies. That is, this statement means this thing, less than or equal to 5. So clearly 1 to 5 after you understood the meaning of this statement. So here is a die through which you play various games that you know very well. Well, that completes the second question. Question number 3, find the probability of the pointer stopping on D in question number first A part. Remember, in all these 3 parts, we need to find probability. That is, we will work on ratios, fractions, whatever you want to call it. And the basic formula we have already studied in the introduction part of chance and probability. Second part is probability of getting an ace from a well-shuffled deck of 52 playing cards, whose concept we shall tell you in depth. C part is probability of getting a red apple. So here is the figure, we need to find it. Let's tackle the A part. We need to reconsider this question first A. So the same has been displayed over here for the reference. We need to find the probability of pointer stopping at D. So how many D's are here? Only one instance of D. So numerator, it should come 1. And this is because in the numerator part, we write number of outcomes giving D. It is only one outcome. And in denominator, for the probability formula, we write number of equally likely outcomes. So in total, we have 1, 2, 3, 4, 5 equally likely outcomes. So this was basic. The answer should be 1 divided with 5. That is one possible outcome of coming D out of total possible equally likely outcomes. That is 5. So that was basic. Now B. Here you need to understand the concept of 52 playing cards. You might have played various games out of it so far in your lives. If not, let's try to give you basic outlook of these 52 playing cards. So if you total them all, simply these are 13 into 4, that gives you 52 playing cards. So these all total are 52. There are 4 types of different cards. Clubs represent this picture. Diamonds, as the name signifies, looks like red colored diamond. And clubs are of black color always. Diamonds are of red color. Spades is a leaf-like structure like this. Again, it is black color. And hearts. So this is the picture of hypothetical heart, although heart doesn't look like this. Again, it is red color. So we observe we have 4 different types of cards whose picture we have shown, and we have a red colors of 2 different cards, whereas black colors of 2 different cards. And the names are like this. These are universal. Whole world knows them with only these names. Also, we have some face cards over here. You can see from 1 to 10, we do not have any face card. 11, 12, 13, we have face card. 11 represents Joker. That's why it is represented with J. Q with Queen, it is the representation of a queen, a female over here. And 13th one is the King. That is the notation of the cards. Also, the first one is termed as Ace. That is, you can say Ace of Spades, then you are referring to this. Ace of Hearts, then you are referring to this. Again, Ace of Diamonds, again this, and Ace of Clubs, like this. So with this idea, let's try to solve the questions. So always remember this basic information about 52 playing cards. The questions on this item will come in future many times, so be prepared for that. With this idea, let's try to solve B part. We need to find probability of getting an ace from a well-shuffled deck of 52 playing cards. We just told you ace means the initial card of each different figure of this deck of cards. So in total we have 4 aces, as you can see over here. So the answer should be 4 outcomes. So we wrote 4 in the numerator part. number of outcomes giving ace we have total 4. Out of what? Number of equally likely outcomes. That is, if we randomly pick one card out of it, we can get any card out of total 52 cards. However, possibilities are only 4. Therefore, in numerator we write number of outcomes giving ace equal to 4, and in denominator we write number of equally likely outcomes 52. Simple enough. So we write 4 over 52, and when you cancel it with 4, 1 4 is a 4, 13 4 is a 52. So the probability is 1 over 13 of picking up an ace out of 52 playing cards. With this, B part has been solved. C. Probability of getting a red apple in this figure. So first of all, let's count total number of possibilities that will come in denominator part. So 3 to the 6 plus 1 is 7. Therefore, in denominator, we should write 7, and against it, we must write number of equally likely outcomes. Now, it is asking for red apple only. So we have 1, 2, 3, 4. 4 instances of red apple in this figure. Therefore, in the numerator, 4 should come, because number of outcomes giving this red apple are 4. So 4 over 7 is the probability of picking up red apple from this bag. That completes our C part. With this, our third question has been solved. Question number 4. Numbers 1 to 10 are written on 10 separate slips. So here we have shown 10 different slips on which numbers from 1 to 10 are written. The same thing written over here, one number on a slip. The same has been shown. Kept in a box, we just rolled them and kept in a box. In this transparent box, or it can be a black box, doesn't matter. And we mixed it well. The whole purpose of mixing is to make all the possible outcomes equally likely to happen. One slip is chosen from the box without looking into it. The whole idea is we do not look at it. That is, we do not have any control that which one we will pick. That is, we have no idea, which can be only known after opening the particular slip. You can simply refer to it as a lottery system. What is the probability of? Alright, so first of all, we have getting a number 6. We wrote getting a number 6. Number of outcomes giving 6. Well, how many 6s we have in this 10 chits? Well, we have only one 6. So we write 1. Now, number of equally likely outcomes. Well, this will always remain same because we can pick any out of these 10 chits. Therefore, total possible equally likely outcomes are 10. Therefore, what is the probability? We write in mathematics by capital P in bracket. We write the event name about what we are talking about. We are talking about getting a number 6. So we wrote getting a number 6. We read it as probability of getting a number 6 is equal to how much? Number of instances that will give 6 is 1. So we wrote 1 in numerator over number of total equally likely outcomes are 10. So the probability is 1 over 10. That solves our first part. Now second one, getting a number less than 6. Therefore, in these type of questions, statement plays a vital role. You must have a better understanding on the language part. It says number less than 6. That is, we must not include 6. Therefore, less than 6, fair enough. We have 5, 4, 3, 2, 1. So total 5 outcomes possible. So we wrote in second part, getting a number less than 6, number of outcomes giving less than 6 will be 5, as we have counted from 1 to 5. And in all these cases, number of equally likely outcomes are 10. We need not to explain again and again. In mathematics, we wrote, this is the representation of therefore sign in mathematics. Probability of what? We write inside brackets the event we are talking about. Getting a number less than 6. So always try to write mathematical way of writing, rather avoiding statements in the answer part. So probability of getting a number less than 6 is equal to how much? 5 over 10. When you solve it, divisible with 5 directly, 1 over 2 is your required answer for second part. Third part, getting a number greater than 6. So we write getting a number greater than 6. We visualize it. Greater than 6 is 7, 8, 9, 10. So we have 4 events or 4 instances for our consideration. We write number of outcomes giving greater than 6 are 4. Now here we must tell you one thing. While understanding it, you may in your rough space or directly on the paper draw the things like this because they are simple enough, small enough to draw. But as you get fluent in solving such type of questions, you must draw these things in your mind and think accordingly. That will come with practice, because practice makes both men and women perfect. The basic essence of life, you must practice it in order to get it. With that said, we just write, therefore, probability of our event in our bracket, that is getting a number greater than 6, is equal to 4 over 10. Always simplify it if possible. It is possible over here. 2 2s are 4, 5 2s are 10. We simply cancelled it out. And the probability in simplified form comes out to be 2 over 5. That is your required answer for third part. Fourth part, getting a one-digit number. Again, basic concepts are repeating. That's why mathematics doesn't leave any concept behind. It concatenates all of them in order to solve real-life problems. Getting a one-digit number. Obviously, we have only one number which is 2 digits. So we have 9 total possibilities from 1 to 9. So we write getting a one-digit number. Number of outcomes giving one-digit number, we have 9. Again, number of equally likely outcomes, we have 10, which remains constant in all these questions. Therefore, probability of what? Event name inside the bracket giving one-digit number is equal to 9 over 10, further not reducible. So that is our required answer for fourth part. With this, fourth question has been solved. Question number 5. If you have a spinning wheel with 3 green sectors. So here we have a spinning wheel. The concept of spinning wheel we just told you in previous question. It consists of 3 green sectors. So 1, 2 and 3. 1 blue sector over here. 1 red sector over here. So let's count total number of sectors. 2 plus 3 is 5 sectors this spinning wheel consists of. What is the probability of getting a green sector? What is the probability of getting a non-blue sector? Again, we have a puzzling statements over here. Just calm yourself and try to answer these questions. So let's first of all try to find the answer of first statement. That is probability of getting a green sector. So how many green sectors do we have? We have total 3 possible outcomes. Out of what? Out of total 5 possible outcomes. That is, without even writing our answer part, we found our answer. It should be 3 over 5. Well, let's write it mathematically. So we wrote probability of getting a green sector. It should be number of outcomes giving green sector. We have 3 instances, 1, 2, 3, because we have 3 sectors which are green in color. So we wrote 3 for that. Number of equally likely outcomes, that is when we will spin it, we do not know, because we do not have any control over its rotation. Wherever it stops, that will be a particular outcome, and it could stop in any of these 5 sectors. Therefore, total equally likely outcomes are 5. Therefore, probability of our basic formula or representation in order to represent probability is this. In brackets, we write the event name, probability of getting a green sector. Therefore, probability of getting a green sector is equal to 3 over 5. Simple enough, not further reducible. That is your required answer for this part. What is the probability of getting a non-blue sector? It simply means it should not be blue, rest of the colors should be there. So we will avoid this color because it is saying non-blue sector. So we have total possibilities of non-blue sectors, that is all colors apart than this blue. This could come, this could come, this could come, this could come. So we have 4 possible outcomes. Therefore, we repeat again, in such type of probability or chances questions, statement plays a vital role. It's the statements which are confusing always. So always break them apart and there is the answer hidden inside them. So therefore, we have 4 events. So we wrote probability of getting a non-blue sector. Number of outcomes giving non-blue sectors, 4. We just discussed how. Number of equally likely outcomes again. While spinning, 5 sectors could come, therefore 5. Therefore, probability of getting a green sector, our event name inside the bracket, is equal to 4 over 5. Not further reducible. That is your required answer for this second part of this 5th question. That solves our 5th question as well. Question number 6. Find the probabilities of events given in question number 2. So we have just produced question number 2 over here. This was the answer which we solved out of question number 2. You may visit on your paper as well. So we were talking about a die and these were the outcomes of our question number 2. Let's try to answer the question straight away. Getting a prime number. So here was the first outcome. We need to find this time probabilities of all these outcomes. Nothing fancy in that. Therefore, we wrote getting a prime number because we were talking about prime number outcomes. So how many prime numbers we found? It was 3. Out of what? Total 6 possible cases whenever we roll a die. Therefore, we wrote number of outcomes giving prime number are 3, which were 2, 3, 5 respectively. The number of equally likely outcomes, it will always remain 6. We told you why. Therefore, in mathematics, we write in bracket the event name. With capital P, we read it as probability of getting a prime number is equal to 3 out of 6, just representing these both digits in fraction form. Further solvable, so it gives 1 over 2 as required answer for first part. Second outcome was outcome of not a prime number. So these were 3 instances of not a prime number. Therefore, we wrote getting not a prime number. So we wrote number of outcomes giving non-prime number. We have 3 outcomes against number of equally likely outcomes that are 6 always. Therefore, in mathematics, we could write it as probability of getting what? A non-prime number. So we wrote inside bracket probability of getting a non-prime number is equal to 3 over 6. Nothing fancy, we are just repeating the same thing again and again. Further reducible, it again comes out to be 1 over 2. That solves the first part, that is 2 sub-parts of first part we have solved. Let's consider second part. So a number greater than 5, we only had one number, that was 6. So we wrote getting a number greater than 5. Number of outcomes giving number greater than 5 was 1. Total possible outcomes were 6. Therefore, we wrote simply probability of what? Getting a number greater than 5 is 1 over 6, not further reducible. That is the answer for this part as well. The trickiest part was this one only, a number not greater than 5. That means it could be 5 and less than that. So we had these 5 instances of it. Therefore, we shall write getting a number not greater than 5 will be equal to number of outcomes giving number less than or equal to 5. So this is the same thing. That is, either we can write not greater than 5 or less than or equal to 5. That means the same thing. So we have 5 instances for that. We have told you how. And in the denominator part, number of equally likely outcomes always 6, because we are talking about a die which consists of 6 faces. And we have no control over the occurrence of any of the face on top whenever a die stops. Therefore, it is a random experiment. Therefore, at last, probability of getting a number less than or equal to 5 or probability of getting a number not greater than 5 is equal to 5 over 6, not further reducible. So that is your required answer for this part as well. With this, our question number 6, which is also the last question of this exercise 5.3. This completes a chapter 5, data handling.